Hey folks, welcome to the NCEA Level 3 Calculus paper for complex numbers from 2024. The way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video just to see how I go about answering them. So without further ado, let's get started. Alright folks, so for question 1, what we've got is given x plus 3 is a factor, find the value of constant p. So basically that means that f of negative 3 is going to equal to 0. So we're going to put down 0 equals negative 3 cubed plus p times negative 3 squared plus 5 times negative 3 minus 12. And when we put this in the calculator, we should get... let's see, negative 3 cubed is minus 27, and then plus 5 minus 3 is minus 15, minus 12, that's going to give me negative 54. So I've got 9p minus 54 equals to 0. So 9p is equal to 54, and then p is equal to 54 divided by 9. So p is equal to 6. And the grade for this question is we're going to get an achieved for this. Moving to question 1b. So question 1b is we've got m cis n pi over 5, where m and n also find z15 given your answers in polar form. Okay, so if we were to do z15, which equals to m cis n pi over 5 to the power of 15, then we actually write this as, well, the modulus in this case, which is m, that's just going to be raised to the power of 15. And then we're going to have cis n pi over 5 multiplied by 15. That's pretty much it, because then you're going to get m15 cis, the 15 divided by 5, they're going to cancel out each other and replace with 3. So you're going to end up with just 3n pi. Okay, that's thought there'll be more to this question. No, that's basically it. That's another achieved question there. Moving on to question C. All right, so for this question, what we've got is solve for x in terms of k. So we're going to square both sides. So we're going to go 4 minus square root of kx equals square root of kx plus 4. So what we're going to do is we're going to square both sides, and when we do this we actually end up with 4 minus root kx multiplied by 4 minus root kx equals kx plus 4. Once that's done, we expand the quadratic on the right hand side, so we've got to do FOIL method here, and what we'll end up with is 16 minus 4 root kx minus 4 root kx and plus kx, because square root of kx times square root of kx is just kx, and we're going to get equals kx plus 4. Now what I can see is I've got kx on both sides, which means they're going to cancel out each other, and I'm left over with 16 minus 8 root kx equals to 4. Then I'm going to go negative 8 square root of kx equals 4 minus 16, and I'm going to get square root of kx equals, now 4 minus 16 is negative 12, and I forgot this negative 8 here, and keep going. I'm going to get square root of kx equals negative 12 divided by negative 8. Then I can say square root of kx equals 12 over 8. Well, the two negatives disappeared, so I'm going to get, what is it, 3 over 2. Now I want x in terms of k, so I'm going to have to square root this one more, it's not square root, square it one more time, and I'll end up with kx is equal to 9 over 4, and then x in terms of k is going to be 9 over 4k. Grades wise, reaching line 1 will get you an achieved. When I say line 1, we are looking at possibly somewhere here. And then this would be a merit for this question. All right, so going to question D. So question D, what we've got is locus is described by this as a straight line. Find the gradient of that line. So what we're going to do is we're always going to do z is equal to x plus iy. So we've got x plus iy minus I equals x plus iy plus 1. So here I'm going to take the modulus of this. So that's going to be square root of just x squared. Actually, I don't need the bracket there because that's the real part, plus the imaginary part, which happens to be y minus 1 squared, equals, and on this side I'm going to get square root of x squared plus y plus, oh no, sorry, I should actually do reals. So that's going to be x plus 1 squared. That's the real part, and then the imaginary part is just the y. So now I've got square roots on both sides. When I square it, the square roots disappear. So I've got x squared plus y minus 1 squared equals x plus 1 squared plus y squared. So I need to expand the quadratic here. So when I expand y minus 1 squared, I'm going to get y squared minus 2y plus 1. And then on this side, I'm going to expand the x plus 1 squared. I should get x squared plus 2x plus 1. And I've got y squared. Now let's see what are all the same terms on both the right hand side and left hand side. So I've got x squared I can get rid of, y squared I can get rid of, 1 I could get rid of as well. And what I end up with is negative 2y equals to 2x, or y is equal to 2x divided by negative 2, which just simplifies y is equal to negative x. So then I can say the gradient of that line is going to be negative 1, because the negative 1 is the gradient right there. So grades wise, getting the final question will get you, final answer will get you a merit. And then writing it in this format here, getting up to this line here, is going to give you an achieved. All right, so let's go to the next question. All right, so for question E, what we've got is we've got two complex numbers, u and v, so the complex number u over v will not lie on the line. Okay, so what we're going to do is we're actually going to do u divided by v first. To do this, we're going to have 2 plus 3ki divided by 4 plus 5ki. Now we're going to rationalize the denominator, which means I need to multiply by 4 minus 5ki over 4 minus 5ki. Now we need to sort out the two brackets in the top, so we've got to actually use FOIL. And so I'm going to do the numerator first, which means I'm going to get 8 minus 10ki, and then I've got plus 12ki, then I've got minus 15ki squared, and that's divided by, I'm going to get 4 squared, which is 16, minus 25k squared I. I just realized that I should have got a k squared there. So that now simplifies to, what do we got? We've got 8 plus 2ki. Just want to double check I'm doing the right thing. I squared is negative 1, so negative 1, so this is the negative 1 here. So this negative 1 times the negative, that's going to give me a positive. So that's going to become positive 15k squared divided by, and I just realized that I forgot another I squared there. Then I should get in the denominator, I should get 16 plus 25k squared. Because, again, this I squared is negative 1, this is negative, so that changes it into a positive. So, simplifying this, I've got 8 plus 15k squared plus 2ki divided by 16 plus 25k squared. Now, it says that it will not lie on the line y equals to x. So what I could do is, if it does lie on the line y equals to x, then the real part is going to equal the imaginary part. Because if you remember, y equals x is like a straight line. And if it's a straight line, then the real part is equal to the imaginary part. So because of that, I am going to go real is equal to imaginary if w is on y equals to x. So we're going to kind of prove that it can't work in there, and that's how you're going to say that therefore it's not going to lie on y equals to x. So if we look at the real part is actually 8 plus 15k squared over 16 plus 25k squared equals the imaginary part, which happens to be 2k over 16 plus 25k squared. Now we don't really worry about the I because we're just looking at the value in front of the I. Now both denominators are the same, so I can write this as 8 plus 15k squared equals 2k. And what I could do is I could write it like this: 15k squared minus 2k plus 8 equals to 0. Now from this point, what I want to know is, can I actually have a value for k where this would actually work out? Because that's going to tell me whether this is possible or not. So what I'm going to do is I'm actually going to work out the discriminant for this. So I'm going to work out b squared minus 4ac. So I'm going to end up with negative 2 squared minus 4 times 15 times 8. And when I do this, I actually get 4. I've got 90. Is it 90? No, 60 minus 80. That's 480. And I'm ending up with negative 476. And I think what this is telling us is that there is actually no value for k where this equation is actually going to work out. So, and that's because of the discriminant being negative. So we're just going to say, as discriminant is negative, there are no solutions. There are no solutions for k. And so because there are no solutions, therefore we can actually say, because there's no values for k, therefore it's not lying in y equals to x. Since no values for k, w will not lie on the line y equals to x. Okay, so grades wise, reaching line 1 will get you an achieved. So that is here. You'll get an achieved. Merit is getting up to this part here. An excellence or E7 is correct conclusion, complete solution with minor error. I think justification and conclusion. So the last two parts there is where you're going to end up with your E7 and E8. And folks, that's basically question 1. All right, folks, so for question 2, what we've got is write the complex number in the form of a plus bi. So we've got I. Let's get rid of that. What we've got is I divided by 2k plus I. So we want to multiply it by 2k minus I, and the numerator also by 2k minus I. So in the numerator, I'm going to end up with 2ki minus I squared divided by 2k squared minus I squared. So I should end up with 2ki minus I squared will become plus 1 divided by 4k minus I squared. That's going to become plus 1. So a value is going to be 1 over 4k plus 1, and b value is going to be 2k over 4k plus 1. Interestingly enough, they actually stopped the question here for an achieved. They're not talking about writing in the form of a plus bi. So actually, no, I think I did have something extra there. Apologies. All right. Anyway, next question. What do we got? We got find the values of r so that the quadratic equation has equal roots. Equal roots basically means that the discriminant is equal to 0. So for us, we've got our a, b, and c. So if we look at it, we've got 3 plus 2r squared minus 4 times 2 times c, which happens to be 3 minus 2r, and all of this is equal to 0. So 3 plus 2r squared is going to become 9 plus 3 times 2r is 6r, so it's going to become 12r plus 4r squared, and then here I've got minus 8 times 3 minus 2r equals to 0. So I've got 4r squared plus 12 plus 9 minus 24 plus 16r is equal to 0. So what I should end up with is I've got negative 15 4r squared and plus 28r is equal to 0. Now, folks, at this point here, I'm not gonna use the quadratic formula here. You can if you want to, but I am just wary of time. So just go straight into the polynomial degree 2 and I punch in 4, 28 and negative 15. So that's going to give me an R value of 0.5 and negative 7.5. And again, this is achieved for both values. That's why I'm not going to sit here wasting time doing something else like doing the quadratic formula. All right, so next question is, given that w over w plus I equals 2 minus I, find modulus of w. So we've got a couple of things that we actually end up needing to do here. All right, so there's a couple of ways of doing this. I mean, you could actually rationalize the denominator, but that's going to complicate it, I feel. The other way is just cross multiplying. So we're going to try the cross multiplication. So that means we're going to put down w equals 2 minus I multiplied by w plus I. So when we do this, we're going to get w is equal to, expanding the quadratic, I'm going to get 2w. 2 times I is 2i minus wi minus I squared. So then w is equal to, what am I going to get? I need to kind of put this in together. I'm actually going to bring all the w's to one side first. So I've got w, this is going to become minus 2w plus wi equals 2i minus I squared becomes plus 1. And then here I've got wi minus w equals 2i plus 1. Then w is equal to I minus 1 over 2i plus 1. Then w equals 2i plus 1 divided by I minus 1. Now that's w in, and I've got to rationalize this at the moment before carrying on with anything. So I'm going to put down w is equal to 2i plus 1 divided by I minus 1. And I'm going to multiply it by I plus 1 and the numerator by I plus 1. And when I do this, I get 2i squared plus 2i plus I plus 1 divided by I squared, what have I got? Negative 1. So in the numerator, I've got negative 2 plus 3i plus 1. Just want to double check that I'm actually on the right track here. Divided by I squared is negative 1 minus 1. So I end up with negative 1 plus 3i divided by negative 2. And I can rewrite this as 1 minus 3i over 2. So now this is pretty much my w, which is half minus 3 over 2i. And once I have that, I should be able to find the modulus. For the modulus of w, that's going to be square root of the real parts, which is a half squared, plus the imaginary part, which is negative 3 over 2 squared. So I'm going to end up with 1 over 4 plus, I've got 9 over 4. And that's going to give me square root of 10 over 4 or square root of 5 over 2. And you can actually leave your answer like that, I think. They've given it in 4 decimal places. I mean, square root of 5 over 2, we can just put that in the calculator just to be on the safe side. We're going to get 1.581. Grades wise, this is, what is it? Yeah, this is just a merit question. So to get up to here is a merit. Reaching line 1, which is up to here, will get you an achieved. All right, so next question. These ones here. So these ones here, one solution is z equals 6 minus 2i. Yes, we know this. What is it? If d is real, find the value of d and the other solutions of the equation. All right, so if one solution of this is 6 minus 2i, then what we can actually say is, because we've got to find the other solutions as well. So z1 is equal to 6 minus 2i, which is the first solution. z2 will become 6 plus 2i, which is the second solution. And there's a couple of ways of doing this question, and I just want to double check that what have they done here. The correct solution for D found and solution for Z2 and Z3. Okay, so the way I would actually do this is, firstly, I'll try and figure out what the D value is. So if you look at the D value, well, that's one way of doing it. The other way is, like, I would actually try and figure out the third solution and then put that in there. And I'll show you why, right? Because the way I'm going to work out the third solution, though, there's a 2 in front. Okay. A silly 2 in the front. I'm trying to do it in a different way than this. Okay, let's try the crazy way. So if this is a solution, then if 6 minus 2i, then I know that the function, because the solution is 6 minus 2, if I go f of 6 minus 2i should equal to 0. So that basically means I've got 2 to the power of 6 minus 2i cubed plus d times 6 minus 2i squared plus 140 times 6 minus 2i minus 200 should be equal to 0. Now, when something like this happens, what you could do is remember that you've got a calculator and you can actually use that. And you can actually use the storing method, right? So what I do is I go, where is z? I go alpha z. So I go and try and find alpha z. Is that going to work? Yeah, there we go, alpha z. And then alpha z is going to be, I think this is going to work. Let me just check this because I always make mistakes with this. 6 minus 2i. No, that's not going to work. I think we got to do it the other way around. Okay, so I'm going to go 6 minus 2i. And I would like you to store it in alpha z. So now, anytime I click on alpha z, I'm going to get 6 minus 2i. So what I'm going to do is I'm going to punch this equation just as is. So for example, if I do z squared, right? So if I go alpha z squared, I'm going to get 32 minus 24i. Now the 32 minus 24i is this part right here. 32 minus 24i. Now what I want to do is I want to do the rest of the parts so I can actually figure out what it is. So I'm going to go 2 times alpha z to the power of 3. So that's 2z cubed. Then I've got plus 140 times z minus 200. And what I'm getting is 928. So I'm just going to write this down. 928 minus 696i equals to 0. So then d 32 minus 24i equals negative 928 plus 696i. I'm not feeling very confident with this one, but let's just see what happens. Then d is equal to negative 928 plus 696i divided by 32 minus 24i. So I'm going to divide this now by 32 minus 24i. I should get negative 29. I'm getting positive 29. Oh, I just realized what I did wrong. Okay, sorry. No, I should get negative 29 because there's I should have put a negative there. Yeah, so d is actually equal to negative 29 because I did do that. That's fine. Checking the answers, d is negative 29. That's fine. So I've figured out what d is. Now to figure out the other two solutions, if we look at the factors of these equations, right? And I'm looking at particularly this one here. What I know is there's a 2 there, which is a bit annoying, that 2. But what I do know is it's going to look something like this. We've got 2z minus k times z minus z1, z minus z2, and all of that is equal to 2z cubed, blah, 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 blah. I don't care about the everything in the middle, and equals minus 200. So in other words, I've got this negative k multiplied by negative z1 multiplied by negative z2 equals negative 200. So what I'm going to do is I'm going to ignore that 2 negatives there, and I'm just going to look at the negative k. So negative k multiplied by negative z1 multiplied by negative z2 equals negative 200. Now negative z, these two negatives will multiply each other to get positive. So I'm talking about these two will become positive. z1 and z2. z1 is this right here, and z2 happens to be this. So then what I can do is I can actually say negative k. In my calculator, I'm going to do this because I'm just lazy at the moment. 6 minus 2i, 6 plus 2i, and that's equal to 40. So from here, what I can then say is k equals negative 200 divided by negative 40, so k is equal to positive 5. But remember that it has 2z minus k, so 2z minus k is equal to 0, 2z minus 5 is equal to 0, and then 2z is equal to positive 5, and then z is equal to 5 over 2. So your third solution is actually 5 over 2. Now this is not the traditional way of doing this question, but it absolutely is fine, because as long as you understand how the roots work and how the solutions work, then this type of question you can pretty much navigate it in any way you want, and you should be able to get the final answer. Now grades wise, well, I think if you find one of them, whether it's the D value, the Z2, or either you find the correct value for D or the solutions gets you an achieved. But if you actually do both, so both, you will get a merit. Single one, you are going to be getting an achieved. So single, when I say single, is like getting either the D or 5 over 2 and the 6 plus 2i. But if you do both, you actually end up with a merit. All right, let's go to the next question. All right, now for the next question, we've got a locus one. So, anytime you see a locus one, just put z equals x plus iy and let it work the magic. So that's what we're going to do here. We're going to put down z is equal to x plus iy. And so when we do this, we're going to get x plus iy minus 1 minus 7i equals 2 modulus of x plus iy minus 4 minus 4i. Now what we've got is square root of all the real values, which is x minus 1 squared, and plus the imaginary ones, which is y minus 7 squared. Just double checking that. Yep, equals 2 square root of x minus 4 squared, and plus y minus 4 squared. Once we have this, we're going to get rid of the square root symbol, so we're going to square everything. Just be mindful that the 2 is going to get squared as well. I'm talking about this 2 here. So when we square this, we're going to end up with x minus 1 squared plus y minus 7 squared equals 4 times x minus 4 squared plus y minus 4 squared. Now we've got this horrible job of expanding it and bringing it all down to a single equation. And that's what we're going to end up doing here. So x minus 1 squared is going to be x squared minus 2x minus plus 1. Then we've got plus y squared minus 14y plus 49 equals 4 times x squared minus 8x plus 16 plus y squared minus 8y plus 16. So simplifying things a little bit here, so I've got x squared minus 2x plus y squared minus 14y plus 50 equals to, I've got 4. I'm just going to do this in one shot because otherwise I'm going to, no, it's okay, I'll just keep doing this. So I've got x squared minus 8x plus y squared minus 8y plus 32. So still nothing changes on the right hand side. Just copying everything down. And here I'm going to expand the brackets. I'm going to get 4x squared minus 32x plus 4y squared minus 32y plus 128. All right, so now I'm going to subtract everything from the right hand side. So I'm going to get minus x squared plus 2x minus y squared plus 14y and minus 50. And when I do this, I'm going to get 0 is equal to 3x squared minus 30x plus 3y squared. 32 and 14y, that's going to be negative 18y plus 78. Okay, so now we've got this situation here, right? And what we do know is that this is got an x squared and y squared. So this is definitely a circle. Now, if you're not comfortable doing, completing the square, I'm going to show you a hack after this, but I'm going to show you the long method first. And then after that, I'm going to show you the hack as well on your graphics calculator. So now 3 is a common factor, so I'm going to take 3 out as a common factor, which means I'm going to get x squared minus 10x plus y squared minus 6y, and then 78 divided by 3, that's going to be 26. Now 0 divided by 3 is just 0, so I'm going to leave it as it is. And I've got x squared minus 10x. I'm going to leave a little gap here, plus y squared minus 6y, another gap, and I'm going to put 26 at the end. Now, because I want to do completing the square here, so I'm going to do half of negative 10, which is negative 5. Negative 5 squared is 25. So I'm going to put this as plus 25. But I can't just add 25 on a straight line, so I need to make sure that I subtract 25 at the end. Then I'm going to do the same thing for the y squared minus 6y. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to go plus 9 here, and I'm going to go minus 9 on the other side. So when I do this, I'm going to end up with 0 is equal to x minus 5 squared plus y minus 3 squared, and then 20 negative, I'm going to get 8. Is that correct? Just want to double check. Yes, I do get negative 8. So then this equation is x minus 5 squared plus y minus 3 squared equals positive 8. Now let's say you want to do this in your graphics calculator. The way you do this is you go into menu and you go into conics. And when you go into conics, there is one, I believe, this one here. There we go. The one in the circle, you can see the ax squared. We're going to click on that. So ax squared, that's going to be 3. Ay squared is going to be 3cy, so negative 18. Wait, what's bx? Sorry, I just got that wrong. B is negative 30. B is negative 30. cy is negative 18. D is the constant by itself, which is 78. I think I got everything there. Cool. Let's draw that. And if I go G-solve, I should look at the center. And if you look at the center, it's 5 and 3. That's pretty much these values here. You can see the 5 and 3 there. So that's the 5. And that's the 3. Then if you look at the radius comes as 2.822. Now this is where, kind of annoying, but you've got to know some numbers. Now if you go back to 2.828, 2.828 squared is roughly 8, and that's where that 8 is actually coming from. So it is a bit tedious, but again, it's just something for you to go and check it out. Now, we have actually got, what do we got? We got, it says the complex number u, which is 3 plus di, lies on this locus. Now, because it's u is equal to 3 plus di, we can say that the x value is going to be 3. So if I substitute 3 in the circle equation, I'm going to get 3 minus 5 squared plus y minus 3 squared is equal to 8. So I've got negative 2 squared plus y minus 3 squared is equal to 8. Negative 2 squared is 4. So I'm going to get y minus 3 squared is equal to 8. Y minus 3 squared is equal to 8 minus 4 is 4. And then y minus 3 is equal to plus or minus square root of 4. So y minus 3 is equal to plus or minus 2. So y minus 3 equals to 2 gives me positive 5. Y minus 3 equals negative 2 gives me a value of positive 1 actually. And that pretty much gives me my complex numbers, which is, so either the complex number is 3 plus 5i, or the complex number is 3 plus 1i. And that's pretty much it for this question, folks. So we've actually figured out what the two complex numbers are. And we've also given it in the Cartesian plane. So grades-wise, grade 1 is, what do you get achieved for? You get achieved here at this line. And then for merit is the 78 part. And for excellence, I guess if you finish it fully and you figure out what the two solutions are, then you are going to finding the two values of y but not connecting these to the values of u. Right. So if you just find the two y values, then you would be looking at E7, but you need to connect it to this part here to actually end up with the E8 mark. Awesome. Let's go to the next question. Let's wrap up question 2 right there. Right, folks, so for question 3a, we've got is right in the form of a plus square root of a. So we're going to rationalize it. So square root of 2p over square root of 2p minus square root of p. We're going to multiply it by square root of 2p plus square root of p over square root of 2p plus square root of p. So in the numerator, I'm going to get 2p plus square root of 2p squared divided by square root of 2p times square root of 2p is just 2p minus p, and I'm guessing this is what I should end up with. I've got 2p plus square root of 2p, because square root of p squared will just become p, over p, and then this simplifies to 2p over p plus square root of 2p over p. All the p's get cancelled and you're left with just 2 plus square root of 2. And pretty much getting here is going to get you an achieved. Moving to question 3b. In the Argand diagram, the point -2, 3 represents a complex number. Show clearly the point representing w, which equals to z squared. So I guess we got to try and work out what z squared is. Because if z is equal to -2 plus 3i, z squared is equal to -2 plus 3i squared, which equals to -2 plus 3i times -2 plus 3i. We're going to get 4 minus 6i minus 12i, and then we're going to get plus 9i squared. So we're going to get 4 minus 12i minus 9, and then -5 minus 12i. So -5 minus 12i, that's going to be there. That's your W. Grades wise, this is going to be worth and achieved. You do have to plot this on the graph to actually end up getting that grade. Often achieved. Right, C, what we've got is given that 3z equals 3 plus di. Okay, all right. Okay, so we've got z, modulus of z, not modulus, conjugate of z is 3 minus di. So we've got 3 minus di equals 10d over z. So we've got 3 minus di equals 10d over 3 plus di. Cross multiplying this, I'm going to get 3 plus di times 3 minus di equals 10d. And I'm going to expand this quadratic. I'm going to get 9 because, well, there are two, what do you call it, sum of differences, sum of squares, I think it is, difference of squares. Oh my god, I'm losing my memory with this, but you know what I'm talking about. The middle part doesn't exist because it's plus, they're the same factors with plus and minus. So I'm just going to do the end part of it. So I'm going to get 9 minus d squared I squared is equal to 10d. So I'm going to get 9 minus, well, minus I squared becomes -1, plus d squared is 10d. So I'm going to get d squared minus 10d plus 9 equals to 0. And that's going to be d minus 9, d minus 1 equals to 0. Therefore, d is equal to 9 or positive 1. So grades wise, getting to which part is going to get you an achieved? I think here. And then finally getting the d1 and d is equal to 1 and d is equal to 9 as a merit grade. All right, next up we've got probably one of my favorite merit questions ever is complex roots. Okay, so we've got z to the power of 4. I'm going to rearrange this as minus 81k to the power of 8. So I need to write this in polar form first. And so before even starting, I'm just going to put this up just to see where it is. So the real part is minus 81 k8. And it has an angle of pi. So then Z4 is equal to 81 k8 cis pi. Now remember that the modulus, which will be a positive value because that's, you know, it's the length of that, so that's 81k8, and then the pi is because it's actually going 180 degrees from the original spot. So with this in mind, I know that there's actually 4 roots in this, which means I need to add 90 degrees to each one of these answers that I get. So then Z1, or the Z is, I'm just going to put Z1 as 81k8 cis pi to the power of a quarter. So then Z1 is equal to 81k8 to the power of a quarter cis pi over 1 over 4. So pi times 1 over 4. So my first Z1 is 81 to the power of 1 over 4. That's going to be 3. If you're unsure, you can just put that in the calculator. So you've got 81 to the power of 0.25. So that's going to give you 3. And then 8 times 0.25 is 2. So that's going to become 3k squared cis pi over 4. So because I have 4 roots, I need to add 90 degrees to each one of them. I'm going to get 3k squared cis, I've got pi over 4 plus, what is it, pi over 2. So you could do it like this. So I just go 1 over 4 like that. And you're going to end up with 3 pi over 4. And then Z3 as 3k squared cis plus 1 over 4. That's going to be 1. No, not 1 over 4. Should be 1 over 2. Sorry, that's my mistake. Because I'm always adding by a half pi. So that becomes 5 pi over 4. And then Z4 will be 3k squared cis 7 pi over 4. Because if I go plus another 1 over 2, I'm going to get that, which is just 7 over 4. Now, this is one of the reasons why I like working with angles in this, because if you had done it in 180, and I'm just going to show you real quickly, that would be 180. 180 divided by a quarter is going to become 45. So that's 45 degrees. 45 plus 90 is 135, 225, and 315. Yeah, that's way more quicker to do with degrees. And there's nothing wrong about you guys doing it in degrees as well. Grades wise, 4 solutions gets you a merit, 1 solution gets you an achieved. So the achieved is here, the merit is when you get the remaining solutions. And I think this is possibly one of the most easiest questions you can get in a calculus paper. I always say when roots come, you just got to go hallelujah and just get it done quickly, because that's like 5 points, easy 5 points right there. All right, so let's go to the last question here. Now this question is just a straightforward algebra question, all right? There's no tricks or anything to this. You've got x plus 1 over x equals to p. You want to find what the value of x cubed plus 1 over x cubed is. So the way we're going to do this is, if I do x plus 1 over x to the power of 3, then I'm going to get p to the power of 3. So all I'm going to do is I'm going to expand the brackets on the right hand side and just leave x cubed plus 1 over x cubed there. And I think if I do that, I should be able to get the rest of the answers, all right? And because you're writing it in terms of p. So we've got x plus 1 over x multiplied by x over 1 over x multiplied by x plus 1 over x. So I've got to do FOIL first for the 2 brackets here. And when I do that, I'm going to get x squared, x times 1 over... So I'm doing this here right now. So x times x, that's x squared. X times 1 over x is going to become just 1. Then 1 over x times 1 will become 1. And finally, I've got 1 over x times 1 over x, which is going to give me 1 over x squared. And this is still x plus 1 over x. So what I've got here is I've got x squared plus 2 plus 1 over x squared multiplied by x plus 1 over x equals still p cubed. So I got to do this whole dance again where I got to go x squared times x and then x squared times 1 over x. So I'm going to end up with x cubed plus x. Then I'm going to do these two here, which is going to give me plus 2x plus 2 over x. Then I'm going to do these. Oh, sorry, let's go with a different color. Then I'm going to do these two here. And if I do that, I'm going to get plus 1 over x plus 1 over x cubed equals p cubed. So putting it all together, I'm going to get x cubed plus 3x plus 3 over x plus 1 over x cubed equals p cubed. Now I want to have x cubed and 1 plus 1 over x cubed on the right hand side. So I'm going to have x cubed plus 1 over x cubed by itself. And on the left hand side I've got, right hand side I've got p3 minus 3x minus 3 over x. Now here's the problem. The answer says you need to give it in terms of p, and I need to get rid of the x's somehow. So what I'm going to do is, and I think this is why this question is annoyingly easy, but it's also something you just need to be visually looking for. So what I'm going to do is I'm going to take negative 3 as a common factor out. And if I take negative 3 out, then what I'm going to get is x plus 1 over x. And if we think about it, originally we actually said x plus 1 over x is equal to p. And because of that, we can then say x cubed plus 1 over x cubed equals p cubed minus 3p. Because this entire thing is actually equal to p. And guess what? We're actually done with this question, because we've actually proved x cubed plus 1 over x cubed as p cubed minus 3p. Grades wise, reaching line 1 gets you an achieved, and for us that case would be here. Achieved. A merit is, it's really weird because I think I did it slightly differently. I guess for, you kind of need to make this connection here to get a merit. I don't know how you can get a minor, I guess you can get a minor error for a E7, but if you get the full question there, you actually end up getting an E8. So yeah, that's basically question 3, folks. Now final grades for this, that's a very generous excellence. A 19 gets you an excellence in this, which is, my opinion, that's actually very, very generous. But yeah, the achieved is from 7 to 13. Merit is actually 14 to 18. Again, that means you only need to get 2 merit questions and a couple of achieved and you can get a merit. So yeah, very generous with the excellence there. So yeah, folks, that's basically it for this exam paper. Any questions, complaints, comments, drop it in the comment section below. Yeah, when it comes to these exams, just take your time answering all the easy questions first, and then spend that little bit of extra time towards the end trying to figure out those crazy questions. All right, so but yeah, just don't leave anything empty with any of these papers. Always try and answer as many questions as possible, and don't leave the exam too early as well. That's the worst thing you can do. Yep, so pretty much that's wrap right there. Good luck for your exams.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.